The goal of the GREAT project is to provide high school dual enrollment and college students with an early STEM intervention in the form of a self-efficacy experience that is in alignment with STEM technician skills and career awareness. We offer this experience through Santa Fe College in a course called The Wide World of Science. The Wide World of Science is offered exclusively at our rural centers at the Andrews Centers in Stark, the Davis Center in Archer, Florida, and the Watson Center in Keystone Heights. A high percentage of students served are of low socioeconomic status and first-time college students from the Alachua and Bradford County areas. Nearly half of the residents live below poverty level, with rural high schools having limited access to opportunities to enroll in advanced science, math, and computer science class. These deficits of access within the school system prevent our students from exploring STEM fields early. And due to the lack of their prior experience in STEM during high school, students are more reluctant towards enrolling in post-secondary STEM courses. In 2012, there was 0% enrollment in STEM at Santa Fe College for first-time college students. Our college believes that more must be done to ensure a larger percentage of students have the confidence and skills to pursue available STEM programs at post-secondary institutions. Some expected outcomes of the GREAT program experience include students gaining self-efficacy in STEM skills and career exploration. 240 students will have completed the Wide World of Science course during the project period at an average class size of 12 students per guitar class. After completing coursework, students will be able to apply college credit to NEAS, AA, or BAS programs. This includes math credit or technical fields at the college. We also expect to evaluate positive changes in students' STEM career attitudes from our program participants. We also expect to provide professional development to faculty to ensure a consistent implementation of STEM pedagogy at our rural centers. The guitar building course offers a pathway to increase opportunities for rural students in the Bradford and Alachua areas with quality access to STEM. The course design offers this experience through different modalities. These modalities include viewing demonstrations, video lectures, and observing diagrams and images. Listening and engaging in guided conversations and discussions also occur, and physically building and manipulating objects. A major emphasis of this project is focused on the future skills of the STEM technician. We do this by situating students in firsthand experiences, applying tasks related to technicians. The build of the guitar is approached in a multidisciplinary nature. We use several other disciplines to learn about the guitar and to make decisions about the guitar design. Some of these disciplines include natural science in wood and plant species, color chemistry, understanding pigment density for swirl dipping, geometric shape areas of the guitar body, electricity, CAD design and 3D modeling, and sound wave frequency. The complexity of dealing with multiple disciplines and managing their roles within building a guitar can be overwhelming for students with limited experience in STEM. For many students, it is their first time holding tools or working with power tools in a project-based environment. To support student activity within the guitar project, we decided to adapt and operate as a learning community of practice. A sense of community was used to support parts of learning the STEM concepts and performing procedure tasks in building guitars. The classroom was used as an environment where we share and exchange ideas and get feedback from our peers. We also use peer pairing to have students demonstrate or model tasks to others. In our community, we intentionally have students interact with the perspectives of their peers as encouragement, and this encouragement helped them to make confident choices and find value in their own work and in others' ideas. Supporting students in a structured community as they move towards making decisions, building, and analyzing STEM concepts did build a sense of ownership and enhance student self-esteem in performing guitar tasks. As we move towards using a community of practice to support our project, the onset of COVID-19 caused our course to be offered in a hybrid format. We used a flipped learning model where students could view video lectures, engage in interactive whiteboards, and threaded discussions online to prepare for our guitar work face-to-face in class. Initially, the goals for supporting students in this online environment was to keep the students connected to the course content and the learning community at a distance, especially for students who were isolated during quarantines. We also wanted to avoid students having an isolated experience by developing more collaborative activities online to maintain group engagement. The use of technology evolved when certain students require accommodation services to support them in their work. We had a variation of student needs that ranged from requiring pre-recorded lectures and documents that were accessible for screen readers. As we experienced new students enrolling with different needs, we saw that it was necessary to look for more ways to leverage technology to support a wide range of students in this blended course format. And we also needed to plan for this blend proactively so that those supports are already embedded in the project experience. One technology that was a major leverage was using video to model guitar building tasks. We did this to help first-timers spatial reasoning by giving them a point of reference for how to proceed in drilling, measuring, cutting the body, and in other related tasks. The reference videos were designed to break down large building tasks into smaller segments to help reduce students' uncertainty and to provide a visual model for how to. We use prompts and cues such as circle highlights, video freezing, and voice narration in the video to orient students' attention towards important parts of the building task. We also use voice narration of each task to help verbally emphasize clear goals for the students as they perform these tasks. Before we incorporated video modeling, the task could only be modeled once before the entire class through a live demonstration. But having video references increased the number of times that students could repeat seeing the task modeled after the live demonstration was complete. In implementing video modeling, students are encouraged to preview these videos before face-to-face class sessions. After discussion, the instructor and TA do a live demonstration of the actual task. This format helped to replicate the modeling for students who needed to see it a few more times before building confidence to attempt the task themselves. With the videos used as a model, the instructor now has the flexibility to move around the room and coach students one-on-one in making their cuts, measures, and drill holes. Every week, students produce digital artifacts that document their building progress with videos, photos, and voice recordings to reflect about their working progress, their accomplishments, and the challenges they may have faced along the way. These vlog recordings and pictures are placed in a digital portfolio so that students can engage with their past work and set new goals for the next phase of the project. The intention of documenting vlogs in a portfolio is to situate students in an iterative routine. We want students to intentionally engage in their ideas about the project and review new concepts they may have learned and set the goals that they want to accomplish within the project. It is also a way that students measure their own growth progress and see their accomplishments along the way to help build their mindsets towards the project. We also use podcasting for students to express their knowledge and make cultural connections to people of interest and the STEM topics that help shape the electric guitar. We use podcasting in the second half of the course as a way for students to begin connecting and expressing their new knowledge about the guitar into a topic that is meaningful to them. This could include topics about the technology that shaped the electric guitar, the wood species used to make guitars, or the people that influenced the sound of the electric guitar. Digital Walls and Padlet was used as a collaborative tool in class for jump-starting and sharing design ideas. We use the Padlet wall as a push to move students towards making their first connections of interest to the guitar project. For first-time students, some have no initial ideas of what their guitar will look like, nor do they have any goals in mind that they want to accomplish in the class. As a warm-up exercise, we have students search the web for photos of guitar bodies, parts, and we ask them to post them on a digital wall collage in Padlet. As the photos begin to appear on the screen in class, the instructor leads a discussion, asking probing questions about the students' interests. All of these technology-supported activities were modeled by video or live demonstration before students were tasked to attempt them. We also experienced challenges with these new supports. The internet was not always consistent in rural areas. Online activities had to be either fully conducted at the beginning of class or reinforced for students who may have had unstable internet access throughout the week. Another challenge came with making appropriate uses of technology. An inappropriate use of technology for learning can cause a barrier to learning instead of a support for learning. So all technology had to be reviewed and analyzed before adding them to the curriculum. We use online discussion to share most of our information as a community. However, social interaction is mostly common on platforms such as Facebook, TikTok, and Snapchat for students. So many students were unsure and sometimes reluctant to use our social platforms for learning situations. So posting, sharing, liking had to be modeled for students to become more comfortable with interacting on a social platform for the goal of learning. Some successes included increased confidence and increased self-efficacy in performing technician skills. The videos help to segment procedures and isolate the building tasks for students. This isolation that occurred in the video helped students to orient their attention towards the important parts of the task, and in result, we experienced lower mistakes on drilling holes, cutting, and soldering electronics. Collaboration and community discourse help students to engage more in their own design ideas and gain confidence in sharing their ideas to receive group feedback. This strategy was used to help build a sense of belonging to the group. Some next steps in the guitar building course includes building a sustainable model for faculty replication. We want to curate the technology that successfully supported our blended course for engagement. In professional development, we want to provide a hands-on experience in guitar building, along with the inclusive teaching frameworks that can support our project-based environment. And this includes frameworks in universal design for learning and culturally responsive pedagogy. Our last next step is supporting our partnership with Upward Bound. We're planning a summer course partnership with Upward Bound, and Upward Bound is a federally funded TRIO program that supports high school students in preparing for college, who are from low-income families and who will be first-generation college students. These students represent a wide range of diversity with limited access to STEM courses. So we want to strengthen these students' opportunity for quality engagement with our curriculum by aligning the course activities with the experiences and the backgrounds of these students. We aim to do this by expanding the curriculum with more practice from culturally responsive frameworks that can support them in not just having access to this STEM experience, but in having meaningful access to this guitar project and to our other great projects in robotics and rocketry.